A newborn dairy calf enters the world with almost no immune protection of her own, just the blueprint for a house that still needs to be built. That means in those first few hours of life, when she's standing on wobbly legs, her body's more like a construction site than a finished structure, completely dependent on the tools we give her to start building. My work focuses on that early window, especially the pre-weaning period, or the first few months of life when that calf is almost completely dependent on a milk-based diet for her energy, which also happens to be the time when her gut is under rapid construction. The gut is the largest immune organ in the body, and in the calf, it's rapidly developing. So it's still putting up walls, sealing doors, and wiring systems that will protect her for life. I study how different pre-weaning diets, such as the one shown on the slide, so milk replacer, which is similar to infant formula, which we typically feed to calves in the field, transition milk, or milkings 2 to 6 after calving, so that sweet spot right between colostrum and the milk we would buy from the grocery store, or probiotics, the microbial additive that has all the buzz in human nutrition right now, influence how that house is built. And I also look at how these different diets affect different regions of the calf's gut. And here's what we're finding. We found that no diet that we fed compared to our control or milk replacer calves affected gut permeability. And that's important because gut permeability gives us an idea of what's passing through the gut and whether or not it kind of should be. So an example would be increased gut permeability may suggest there's some leakiness happening. And that leakiness could mean that pathogens are maybe getting out to places they normally wouldn't be going or shouldn't be going. And that may mean our nutrients aren't being absorbed as efficiently or being used for their intended purpose if they're bypassing their absorption mechanisms. Structurally speaking, we measure the surface area along several regions of the gut. And we do this because it's a really good proxy for how efficiently we can absorb nutrients. And so when we fed calves transition milk, they tended to have greater surface area along several regions of the gut, suggesting to us that maybe they're absorbing nutrients a little more efficiently than their counterparts. Next, we looked at how early nutrition can influence the immune landscape along the gastrointestinal tract. That's important because it gives us an idea of what players are playing in the immune system team at a regional level. And what we found is that a probiotic supplementation early in life could actually influence some of those populations we would typically associate with either an immature or more mature immune phenotype. And that's important because we can help accelerate maturation. Maybe we can help set up calves for success. And so what we're finding is that when we nourish the calf's gut from day one, we don't just help her build a house. We help her enhance her natural structure and processes that she was born with. A calf gets one chance to build that gut and home right. My work is about making that moment count.